Good day guys, welcome to Tony Tech Pro. In this video I'm going to talk about wireless communication, but before that I will try to this session is just the theory part. After explaining about wireless communication, we'll go into the practical aspect. But first of all, before we go into the practical aspect, we need to understand the theory aspect of it. So stay tuned. After the explanation, we go to the practical aspect. So in this lesson, when we say about wireless communication, what do we mean by that wireless communication? Simple. A wireless communication in a layman language or for beginner level is that it's a transmission which is done through wireless form. What do I mean by that? I mean that is a communication between the sender and the receiver, between the sender sending the information to the receiver without any sort of physical connection. If we talk about wireless communication, you can see we have many modules using wireless communication. But in this video, I'm going to make it simple. We are going to use the simplest and the cheapest module for beginners, for those that don't know how to build or that have not heard about wireless communication. We will talk about the transmitter module and also the receiver module. Don't mind, this is just a sketch. I will also show a picture of the module. But this is just a transmitter. This is just a transmitter, while this one is a receiver. And in order to get our information, we need what we call encoder and decoders. So we have so many encoder and decoder using wireless communication, but the one that I will show you here is the one that I find around me, the one the one that is easy to access. So first of all, let's talk about this HT12E and HT12D. This E here means encoder, while this D means decoder. So this is a typical symbol of the IC. I also laid out the pinouts of this IC, and I'm going to explain what the IC does. So let's go to the encoder side. This HT12A is the encoder IC. This is the IC that will encode your information and transmit it through this transmitter module. So how does this encoder works? We have if you look at it, we have A0 to A7. This is the address line. I will talk about what this address line is all about. And if you look at this side, you will see AD0 to AD3. This is the address data line. So, and this is their pinout in respective of the IC. The A0 is pin 1. You can see it, I've labeled it out here. So this address line is, in order to communicate with the decoder, the two address line must be the same. What do I mean? Just for like example, when you are sent for an errand to deliver a message to someone, the sender will give you the address of the person that will receive the information, that will receive the package. So in order to deliver the package to the right person, you need the address of that person. If you miss the address, that means you are giving the package to a wrong person. So in order to deliver the package, you need the address of the person in order to deliver the package. So that is just the simple thing about these two IC, the encoder and the decoder. In order for this encoder to send this information and this decoder to enable to receive the same information which is being sent by this encoder, the two address line must be the same. And in order to set this address line, this is the pin in order to set the address line from A0 to A7. This is the address line. While the data we are being sent is from this AD0 to AD3. Okay, so I will show you a typical example of what I mean before we go to the practical aspect. But first of all, let me explain all the pinouts. So like I said that the A0 to A7 is the address line. It is used to set the address, and the pin 9 is the ground. AD0 to AD3 is the data line, address data line. This TE, this TE at pin 14 of the encoder is the data output enable. This pin is active low pin, so which means once you put this pin low, the data output will be enabled in order to transmit. And once this pin is put high, this data output cannot be transmitted. Okay, and this oscillating 1 and oscillating 2, this IC has an internal oscillation, and in order to set it, we have what we normally connect a resistor between this oscillating 1 and oscillating 2. The range of the resistance depends, but I normally use 1 mega ohms resistor. So I will also show you the diagram. Likewise, let's come to the decoder side, the HTD12. This is the decoder side, the same thing. A0 to A7 is the address line. You need to set these both IC in the same address in order to receive information. And this pin, so you see VT. This VT is just a signal, LED signal. We normally connect LED signal to it in order to see that this IC is receiving signal. And the input data is the one that receives the data being sent by this encoder. Okay, and the D0 to D3 is the data pin. This is the what will display the information that is being sent by this encoder. So let me quickly show you the schematic, and then before we go into the practical aspects. So here is the schematic of it. Like normally I purposely put this push button in order to show you how to select the address line, but normally some people used to put all this address line to ground, put the encoder address line to ground, and also put the decoder address line to ground in order for them to have the same information. But the reason why I want to show you a practical aspect of what happens if these two IC does not have the same address. So I use this resistor. Don't mind the color, I just use the color to beautify the resistor. But this is resistor. You can use 1 kilo ohms resistor in order to put all these pins to ground. So what I did is that I put all this address pin to ground and use a pull-up signal by connecting each of them to a push button, in order so that if I press this button, this pin will be pulled high. If I release the button, the pin will be pulled low. So that is what I did here. And also the same thing that I did also to the data line. So as it is now, this data line, the signal that is here is 0, is being pulled ground, and we know that ground means 0, active high means 1, which is either 5 volt or okay. So that is what I did. And I also put this a push button to this TE enable, the transmitter enable. That is the full meaning of that TE, transmitter enable, in order to show you what happens once if you want to enable the signal, or if you want to disable the signal. And this is the resistor that I'm talking about in that oscillating part, that it needs to be connected like this. And this is the output signal from the encoder to the transmitter module. And we know that this transmitter module, this is the VCC that need to be connected to the positive. This is data in the pin that received the data, and this one is the ground. Other things attached to the module, you need to see it physical. When you buy the physical the physical module, you see other components that make up the module. And normally some people used to connect an antenna to the module for a wider range, and know that this module is limited based on the range they can go. At times, once you put antenna, it will go up to 1 meter or above. So, but this range is limited; it can't go beyond their limit. So that is it. So this is the receiver aspect. I also put the address line to ground. Likewise, the way I did the encoder side, and this is the output signal. So that once we send a signal through this data line, we can be able to receive it from this the decoder. So this will show us the physical aspect of the data that we are sending. And also the same is being done to the receiver using a resistor. And this VT is where I connect the signal LED. You can see it here. And the receiver module has VCC, data out, and ground. The data out will go into the input of the decoder. So that's it. But this I have another encoder and decoder IC that I have in hand. I don't have this HT12D, HT12E. This is the one that I have. This is M145026. This is the encoder, while this one is the decoder. All of them work the same. The only difference is this resistor and the capacitor. That is the only difference. And I don't think this really matters to the IC. Okay, but you will see based on their label, you see in the decoder side, you see where the label R2C2. That means the resistor and the capacitor will be connected together and be put ground. You see C1 arrow 1. So that is how to connect the decoder of this IC, and this is how to connect the encoder of this IC. This IC, this encoder and this decoder works the same as HT12E or HT12D. They work the same. The only difference is the capacitor and the resistor. So in order for these two to communicate, the address line must be the same. So I will show you that in the practical aspects side. So let's go to the practical aspect side.
So guys, this is the whole setup. Like I said, I don't have the HT12E and the HT12D, so I decided to use you can see it, I decided to use the M145026, the encoder, and the M145027, the decoder. So first of all, look at the module of the transmitter. This is the transmitter module. You can see the pinout, ground, data, VCC, and the antenna that I said. And this one is the receiver module. You can see it has, I don't know why it has 3 ground in the module and 2 VCC with 1 data output. I don't know. Their reason is best known to them. So let's watch that. So this is the ground, VCC, data output. So that's the pinout of the transmitter and the receiver module. So let's go to the encoder IC and see their pinout. Like I said, this is I use the logic gates signal in order to, instead of using the resistor and the push button, the whole circuit might be complex, so it might be confused. So I decided to use the logic gates signal in order to simulate the address line and the data line. So in this encoder, you can see the TE, the transmitter enable. This is its own logic signal, and this 1, 2, 3, 4 is the data line of the encoder that I use in sending the signal. What's the arrangement of it? This is D6, D7, D8, D9. So likewise the address line is A1 to A5. Okay, and this is ROS CT, like the way I showed you in our theory aspects. how to connect it. So resistor, capacitor, and another resistor. The value does not matter, I don't think so. The value matters. So the output signal from this encoder will be fed into the data input of this transmitter module. Okay, so there's not much to talk about the encoder. Let's go to the decoder side. Look at it. So this is the VT. I know this wire will be so confusing, but this VT is this signal. The way I rotate this LED in a reverse way is that once this encoder signal is low, this LED will not be on, but once I send a high signal, the LED will be on. So no, sorry, once I send a high signal to this decoder, the LED will be off, and once I send a low signal to it, the LED will be on, because the way I rotate, the way I connected the LED, you can see this is the anode of the LED being put high, and this side is the cathode of the LED being connected to the data line. See the data line, and this one is the address line of the decoder. So based on this D in is what will be fed in this output from this receiver module. And likewise, the way I showed you how to connect the receiver, the decoder, the capacitor, and I know I made a lot of mess in this connection, but that's why I just draw the diagram on paper for you to understand. So what you're seeing here is the typical diagram that I do on paper, is what you're seeing here. So the whole aspect of this is to show you how this transmitter works. So let me simulate it. Let's see what is going on. Okay, now you can see the signal. This is the LED signal line from the VT. It's blinking, and if you this LED red LED is being connected to this DCs. This LED is being connected to DCs, and if you watch the DCs, which is this one, is being low. So the logic signal is low. So that is it. And what this address line, if you watch this A1 to A5, this is 1000, as in high low. This 0 means low, this high means positive voltage. So if you watch the address line 10000, and if you watch the receiver, don't mind the way the orientation of this IC. If you watch the address line of this IC, see that it is same thing. The A1 address line is 1 from the decoder side, and others is 0, just like the receiver side. The encoder side, the A1 is high and others is 0. So once I put these things, all these things are high. That's why these LEDs are low. So watch what happens once I put, and this signal will correspond to the data line of the decoder. So from this is D6 to D9, and we have D6 to D9 too. So once I put D6 high or low, it will also send a signal to the D6. Just like I said, this D6 from the encoder is low, and the D6 of this decoder is, the LED is on, because the way I connected the LED. So let me turn the rest. So once I make this one low, you will see that D7 is also turn on the LED. Watch, it will also turn the LED. So see, this is the way we send the information. So let me show you what I mean by it. And okay, first of all, look at the transmitter enable, and I told you that this transmitter enable is active low pin. So in order for me to transmit signal, if I put this pin high, I cannot be able to transmit signal. And if you watch this decoder, you see that the LED stop blinking, and anything that I try to do here will not work because the transmitter enable is being disabled. So once I enable it, all the signal that I've transmitted will be available here. So let me show you what I mean by the address line. Watch, if I change this address line of this encoder 00, watch, the signal just stop and this thing stop blinking. Any signal that I try to pass will not be sent because these two address line are not the same. The encoder address line is 00 throughout, while the decoder address line is 100. So if you see, the address line are not the same, so any information that I'm trying to send will not be received by the decoder. So in order to receive the same information, you must make sure the address line is same. Watch, so I've turned on the address line to be the same, and you can see this is the information. So that is it. So guys, that is how to build a wireless communication. So this is just the first aspect of wireless communication being built manually. Another video will be how Arduino can be able to communicate using this transmitter and receiver module. Okay, so thanks guys for watching. Please make sure you subscribe to our YouTube channel and click the notification bell in order to get notification when we upload any video. Thanks, love you guys.